friends, in this video we are going to create Gaussian blur algorithm from the scratch. For that, if you have not seen my previous video in which I have discussed what is blur imaging algorithms does and how actually they work, so watch that video for the better clarification. Otherwise, let's get started. So first of all, we are going to import the library. So import cv2 to read the image file, then import matplotlib for the visualization of the image. So matplotlib.pyplot and as plt for the easy, and next one will be our import numpy as np, and one thing also we are going to import is math. Import math for the calculation of the Gaussian formula. Now create a class that is Gaussian Blur, that will be our class. Then initialize the class init that is self with the self. Now in that we will pass the image. First of all, the image path. So self dot image will be our image we will send from as object. So here, and to get create a object, let's blurred image. We are creating a object blurred image equals to the our Gaussian Gaussian blur, and inside that we will pass the you can say path of the file. So our file is this is the I've downloaded the file. This is the image, we are going to blur it. So this is the cat. So write down, we can copy the name of the file, copy path, then paste here, paste. Now we get the image over here. Now after that, what we are going to do is, let's self dot kernel size. Now we have to put say our kernel size. So our kernel size we will pass here. Initially it could be let's say 5, and we will pass from the object also. So we are going to pass here from here. So kernel size will be, let's say I've said, you can choose yourself how much blur you want. So you can choose your kernel size also. So k will be k, and next one will be our self dot mid which is middle. We want now what is the middle location of the kernel. We will discuss it later why we are doing it, but for now mid equals to the k by half. We are taking the half of the kernel size. Let's def create a function for the blur. In that we are pass the self values from the blur self, and then now first of all what we are going to do is, we are going to first of all create the visualize the image. Okay, so for the visualization, let's image equals to the cv2. We have already done it in previous video also, no? So I am read, and what is we are reading the image which is self dot image, that is our image, and we are going to plot it. Let's plot it. Plot plt dot I'm show, which is library from the matplotlib, and in that we are going to pass image, and next is plt dot show, and this one, and now we are going to run this function. So we have created object blurred and a blurred image, and this one image, and inside that dot our function blur, which is our function. Let's run it. Let's say what happens. Now we get our image. Okay, something is wrong. We have already seen because in this image you can see this is a different color, and in this the image is different. So we have to convert it. So because when we render the image from the cv2 library, it gives us which form? It gives us BGR form, but we have to convert it to RGB to get the real image. Okay, we need RGB image. So convert it. So image equals to the, we will do convert. So cv2 dot cvt convert cvt color, which is our color. Convert color, and which image, and then we will pass the cv2 dot color, which is color. So color BGR to RGB. Now if we render it, let's see what we get. we get now we get the original image which we wanted here. So now we have converted to the RGB image. So what we have done, let's write here. So we have BGR to RGB color. RGB. Now next, what we are going to do? Now next we are going to create a kernel which is Gaussian kernel. What is the difference between normal kernel and Gaussian kernel? It is the major difference is its kernel value will be bell shaped. Means in the normal kernel we take 1/9. If kernel size is 3/3, we take 1/9 for each the values in the kernel. But in the Gaussian kernel we take the value on the basis of their distance from the middle one. We move far from the middle of the kernel, we get the lower and lower weightage for that. So we are going to create a kernel. So for that we are going to create a def, that is our function, and function name will be create kernel will be, and in that we will pass the self. Now we will see why we have taken the self dot mid here. So for that we are going to first of all create a normal kernel. So kernel we get the kernel which is np dot zeros. So we are initializing our kernel with the value 0, and in that self dot k, which is our kernel size, and self dot k, which this is our initial kernel, and define the data type the np dot float 32, that is our size. Now this is our kernel size initially. Now we are going to do is we want to bell shape values, like in the middle one we want 0 0, and as we go further their location -1 like this, and this side +1 So we want location from the middle position to the other ones. For loop, create a loop I in your range in which kernel dot shape and 0. And next in that loop we are creating a second loop, so for the row and the columns. So range and kernel dot shape and 1, and in that we need a x value. What is the x value? Basically the location, x location from the middle one. So we want the distance from that middle one. So x will be our I minus and self dot mid, which is mid base kernel, base location of the middle of the kernel, and the I value which is let's say 1 or 0. We will start with the 0 now, first row, first column 0, and we will minus it middle one, so we get the location. So x and y location will be z minus self dot mid. Okay, now we will see x and y. Now we are going to implement our Gaussian function. So kernel value will be I and j, for the j location for that. And what is the Gaussian function? On your screen you can see this is a Gaussian function. In that we have, what is the basic function is, it is 1/2 into pi and sigma square. What is a sigma? Sigma is nothing but a standard deviation. We can see that if we increase the sigma value, then we get the more weightage differences. Means far will be more lower and middle will be much higher. So this difference is designed, or you can say decided by the sigma. So we will start 1 divided by 2 into pi, which is math dot pi, into we will get the value which is sigma square. So this is the our base function, which is we are going to multiply with the exponent, which is exponentiate the values weightages for the far and the middle ones. So let's do it into, we are going to multiply and math dot xp exponentiate and minus, and in that we are going to pass x. Our x value is, so x and 2 plus y square, we get the y square, and we will divide it by the your sigma square, and we will divide it by the 2 into sigma square. just let's see any mistake here. Let's write down here. Now let's print it out. Let's print and see how this actual kernel look like. So let's return it. Return kernel, and now we are going to call here kernel. So we are going to call kernel equals to the self dot kernel, which is our function, and this is our function. Let's call it, and we are not going to plot it right now. We are going to print the kernel only. So print the kernel. Let's run it. Let's run it and see what we are going to get. Gaussian Blur has no attribute called kernel. Why not? There is a spelling. Okay, this is a create kernel. So we are going to pass a create kernel. Now there is sigma is not defined. Okay. One thing is we have not initialized the value of the sigma here. So let's initialize here self dot sigma, and which will be sigma, and we are sending from the main object creation values. So sigma equals to the, let's put it 10 here for now, and we can pass here also from these values. We can pass here, let's say sigma value is 20. We can do whatever we want and how much we smoothness we want. Okay, so let's see this, and sigma is now defined, and here it should be self dot sigma, and here also it should be self dot sigma. Now let's run it. Let's see what it gives. Now we are getting the values here. What are these values? You can see these are values which we are getting from the Gaussian function. This is our kernel. Now one thing we want more here is we are going to divide by sum, because what is this function is giving a values, but this is not a normalized value. No, these are the normal values from the on the basis of their distances of the exponentials. They are the exponential values. Now we have to normalize it. So our kernel will be kernel equals to the divided by kernel and sum of the kernel dot sum. That is sum of the kernel. We are dividing it to get the normalization. So this is what we'll get, normalized kernel. So now run it and let's see what we get. We should get the normalized kernel. So this is our values, and this is now normalized to the all the sum of these values will be equal to the 1. Now next step, we have now created our successfully our kernel. Now next same thing we will do. We have already done that. So let's create a blurred image, which we have done in the previous video also. Blurred image, and that will be NumPy zeros like and that is zeros like image. Now we have created a zero image matrix with the size of image. Now we are going to for loop it. For I in range image 0. Then next is one thing before going forward, we have to get the channels also now. So for C in range there are 3 channels, so range 3, and then for each one we are going to map loop it. So before this we have to pad it. So padded image, padded NumPy.pad, and in that we are going to pad which we want to pad, that is image, and that is comma, and for the C value we are going to pad, and mode will be our edge, and there should be a pad width. Let's pad width. That will be a same. We have already mid self.mid. We can put it self.mid. That is half of the kernel. And now this is our padded image. And for J in range, for the column and the that ones. So dot shape. Here we should add the shape also. Shape. Now we want our region. So region equals to the padded image. In that we are going to put I, and to the I plus self dot k, and j to j plus self dot k. Now these values padded image, we get our region, and for each region we are going to put the values in the blurred image. So blurred, this will be our final. So blurred image, in that we are going to put I j for the ij location, and C channel we are going to put the values which is np and sum, there sum, and in that region into kernel. We are kernel multiplying with the, and this is the this is giving a blurred image, and we can return it, return blurred image, and we can plot it. Let's plot it here, remove this, and let's plot our blurred image. So here we will get final image equals to our blurred blur, and let's plot it, plt dot im show, and which is final image, that is final image, and plt dot show. Let's run it, and before that let's set the kernel size to 9. We have successfully created our blur image. It had taken more time than actually in the production based they use, because they are using the C++ or C language for that, but it was good for the learning purpose only. For production base, we will try in the future upcoming videos, if it is possible, then I will try to show how we can do that C++ code faster working from the scratch. Otherwise we can use the OpenCV or other libraries for that, but it was good for the learning purpose.